I am sure you all have seen a tire and know what shape it is. Yes, it is a circle. Here, in this video, we will study about the parts of a circle and an important theorem from chapter 10 and do exercise 10.1. First, let's start by learning about various parts of a circle. Here, we have a circle. This point is called the center of the circle. The constant distance from the center of the circle and any point on the circle is called radius. A line segment joining any two points on a circle is called chord. A line segment which passes through the center of the circle and its endpoints are on the circle is called diameter. The length of the outer boundary of a circle is called its circumference. Any part or segment of the circumference or outer boundary of the circle is called an arc. A sector of a circle is a portion or part of a circle that is composed of an arc and its two radii. A segment of a circle can be defined as a region bounded by a chord and a corresponding arc lying between the chord's endpoints. Let us now examine the different situations that can arise when a circle and a line are given in a plane. So, let us consider a circle and a line AB. In this picture, the line AB and the circle do not have any common points. So, in this case, AB will be called a non-intersecting line with respect to the circle. What do you think about this picture? Yes, in this the line AB is intersecting the circle at 2 points and is called the secant of the circle. And lastly, in this, the line AB and the circle have only one point in common and is called a tangent to the circle. Next, we are going to study and prove the theorem 10.1. The theorem states that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now let us prove the statement of the theorem. We are given a circle with center O and a tangent xy to the circle at a point P. We need to prove that OP is perpendicular to xy. Take a point Q on xy other than P and join OQ. The point Q must lie outside the circle. Why? Because if Q lies inside the circle, xy will become a secant and not a tangent to the circle. OQ has a point on the circle also. Let's name it R. OR is also the radius of the circle. This means OR is equal to OP and OR is less than OQ. This implies that OP is less than OQ. Since this happens for every point on the line xy except the point P, OP is the shortest of all the distances from point O to the points of xy. According to shortest distance theorem, the perpendicular distance is the shortest distance between a point and a line. So OP is perpendicular to xy. Hence, proved. By this theorem, we can also conclude that at any point on a circle there can be one and only one tangent. And the line containing the radius through the point of contact is also sometimes called the normal to the circle at the point. Now, let's start the exercise 10.1 from NCERT. The first question is, how many tangents can a circle have? Think about it yourself. Yes, the answer is infinite. Because we have studied that there are infinite number of points on the boundary of a circle and each point can have a different tangent passing through it. Hence, there can be infinite number of tangents. Question 2 is, fill in the blanks. A tangent to a circle intersects it in dash point or points. What do you think will fill the blank? Yes, the answer is 1. A tangent to a circle intersects it in 1 point. A line intersecting a circle in 2 points is called a dash. Think for yourself. Yes, the answer is secant. A line intersecting a circle in 2 points is called a secant. A circle can have dash parallel tangents at the most. How many do you think they are? Yes, it is 2. A circle can have 2 parallel tangents at the most. The common point of a tangent to a circle and the circle is called dash. Try once. Yes. It is called the point of contact. The common point of a tangent to a circle and the circle is called the point of contact. The next question is, a tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ is equal to 12 cm. What is the length PQ? Let's make the circle of radius 5 cm and center O. Also, construct a tangent PQ. We know that the length of OP is equal to the radius, which is 5 cm. Also, we know that the length OQ is equal to 12 cm. Using the theorem we studied, which states that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So, angle OPQ is equal to 90 degrees. So, we have a right angle triangle OPQ. Using Pythagoras theorem, we can write PQ square is equal to OQ square minus OP square. PQ square is equal to 12 square minus 5 square equal to 144 minus 25. Hence, we get PQ equal to under root 119 centimeters. So, the last question is, draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to the circle. Let's draw. First a circle, then a reference line. Now we have to draw a line which is parallel to this reference line and is tangent to the circle. Here it is. And lastly, we have to draw a secant to the circle which is also parallel to the reference line. We hope that you have understood the concept of circles. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve answer-based MCQ tests of this chapter on EduRev. And that's not all, you also get amazing courses for Class 10 and much more for your Class 10 preparation. Thank you.